Here we come to A-Level Physics 2003 question 3, which shows a part of a stroboscopic picture of a particle projected into the air. Because it's just part of the photograph, we can expect there is some path when you go back into time, and of course this can be extend forward as well, but this is just part of the trajectory. And because of this, we can expect that even at the first position here, the particle is already moving with a horizontal component of the velocity and a vertical component of the velocity. So it is already moving. So now we start from this point. We assume t equals 0. At this point, we take this at the beginning. And we count the displacement of the particle at other times. For example, like in the next position, the stroboscope has flashed one more time. So t is equal to t, and in the next position, the stroboscope has flashed for one more time, so the time would be 2 times the period of the stroboscope. So at this 2 position, we focus at the vertical displacement. In the first level, okay, the original position is here, and at t equals 1t, the position is here, and when t equals 2t, the position is here. So the particle has moved down for 3 boxes, that is 0.15 meter, within 1 period of the stroboscopic flash. And the particle continues to move down, and at the time when it has 2t, it is 2t, the particle has moved for 0.4 meter. So we can write down 2 equations of motion. Firstly, consider this displacement. We know that S is equals to ut plus half a t squared. So for the first displacement, we can write down 0.15 equals here we had spent 1 period. Okay, so we set up one equation, and then we consider the second part of the motion, measured from the beginning of time to 2t. It moved for 0.4 meter. So I would just write down the equation. This time we have spent 2t. So now we have 2 unknowns, ui and t, but we have 2 equations. So supposedly we are able to solve this equation. So how to solve this equation? We just try to use equation 1 multiplied to 2. So it becomes 3. So and then we do the subtraction. Uy times 2t cancels each other, so we don't need to care about that. So here we find that t is equal to 0.1 second. And with t equals 0.1 second, the frequency of the stroboscopic photograph will be 1 over period. So it will be given by 10 Hz. So the answer is C.